Hi everyone, and welcome to this ASHRAE Ireland technical webinar on the use of optimization techniques as a design stage cost-benefit analysis tool with Nishesh Jain, who is a PhD and research fellow at University College London and working in conjunction with DesignBuilder. So before I hand over to Nishesh, I'm just going to go through a couple of housekeeping items. So I'll just take a couple of minutes at the beginning before I hand over to Nishesh. And we'll also have time at the end for some Q&A from the audience before I finish up at around 2 o'clock with some closing announcements. So you'll have noted everyone who's joined, you're muted by default. But if you do want to ask any questions during the course of today's session, please do use the chat function to type your question at any stage during the webinar. You'll also have the opportunity, if you want to ask a question directly, you can use the raise your hand function. So that's under, the appearance may look a little bit different depending on what platform you're using, but in Zoom, there should be a reactions panel that allows you to raise your hand at any point during the webinar. If you do have any difficulty or you want to follow up afterwards, you can email me directly using the email address on the slide. The handouts for today's session will be available shortly in the chat, and they'll also be available afterwards on our website on the webinars page. This is part of our ongoing series of technical events and training over the course of the year. I've highlighted here on this slide some of the events that we've held so far in 2021. This week we're also running ASHRAE HVAC training for the first time virtually since we last ran training in 2019. And we've also got a number of webinars scheduled before the end of this year. So you'll be able to access the details for all of these on our website or on the slides. You can click through the links to register for upcoming webinars or view any of the previous recordings. I'd also like just to highlight the availability of the ASHRAE Learning Institute, which provides complimentary CPD accredited training and events through the ASHRAE.org website. So the link is on this slide, and you can access the details to join any of those sessions from the ASHRAE.org website. So I'm going to hand over now to Nishesh Jain, who is, as I said, a KTP associate and research fellow at University College London in conjunction with DesignBuilder. Nishesh is an expert in the area of energy modeling, building design, and optimization and energy model calibration. So he's going to talk today about the use of optimization techniques during the design stage of the building process. So I'll hand over to you, Nishesh. Just let me stop sharing.
Thanks, Daniel, and thanks for introducing me, and just share my screen. Yep, okay, so hopefully you can see my screen now, and thank you everyone for joining us for the presentation today. So in this webinar, I'll have two main aims. One is to explain to people what optimization is in a building performance simulation context, and with its implementation and use within the DesignBuilder software environment. And then I'll show you some case studies to illustrate how powerful optimization can be to help you design high performance buildings and inspire you to use in your projects during design. So let me see, what slide is that? Yeah. So the presentation will first briefly introduce you to DesignBuilder software, and then after reviewing the basic concepts about app optimization, I'll show you how those concepts are implemented in DesignBuilder optimization interface. I'll use a 5,300 square meter college campus building from a past optimization project to illustrate optimization of both HVAC systems and thermal envelope of this building. And then I will show some more example studies on how optimization software has been used to design high performance buildings. That would cover various applications such as ground source heat pump optimizing, or optimizing a residential home, and also a detailed workflow on how to go about a net zero office building design that was done using the optimization tools. In the end, I'll also show you various resources where you can learn more about optimization and how you can use it within the software. And by the end of the webinar, in my view, you should have a clear understanding of key optimization concepts, how those concepts are applied on the real world projects, and how you can, if you want to explore more, where you can go and get inspired. So yeah, so before I dive into the details of optimization, just a quick overview on how optimization connects with DesignBuilder more widely as a software tool and with energy modeling tools. So DesignBuilder is a fully integrated simulation toolbox. It's a graphical user interface that enables you to use global gold standard simulation engines like Energy Plus, Radiance, OpenFOAM in faster, easier, and more productive ways. DesignBuilder is a very mature and capable third-party interface to Energy Plus, which is the simulation engine used in optimization as well for the parametric studies. And all of these engines are integrated within the DesignBuilder interface. So all these analysis can be run from one single model. So once you have built your model, you can either do it by importing your BIM model or using GBXML or IDF import, or model it within DesignBuilder's modeling tools, which are quite good. You can use that one model to assess energy, comfort, environmental performance, or then you could run large variety of compliance calculations, including lead preamp. You can also run daylighting, CFD simulations, etc. And my favorite part is more on doing advanced scripting, which is DesignBuilder has the most advanced capabilities on doing those in mainstream tools to expand the horizons of your simulation modeling. But our focus today is on optimization tools that provide powerful ways to do advanced cost benefit analysis at design for your design projects. So you hear people talking about optimization all the time, and a lot of people talk about it. But the word, in my view, is used in different ways and can mean very different thing to different people. So optimization can be often loosely used to describe relatively minor or incremental improvements in design as you go into the iterative design process. But what I'm talking about in this context is not that. What we are presenting is multi-criteria cost-benefit analysis using genetic algorithms in an automated process to find optimal design solutions. So until fairly recently, this was only possible in academic circles and involved a lot of time consuming code-based tools, and which were useful in research context, but weren't viable for industry to use in a commercial environment. So in 2013, DesignBuilder introduced a first commercially viable optimization tool in a mainstream software. And then its capabilities have significantly increased and is now a go-to option for many firms and people to work towards. And we will see how what all can we do using these tools. So optimization is increasingly necessary part of the design process for high performance buildings, because buildings are complex ecosystems. It has thousands of different elements that interact with each other, such as fabric, glazing, shading, HVAC, lighting systems, and many more. Changing any one of those elements will have a knock-on impact on others and leading to numerous permutations and combinations. So let's see, for example, if you have an option to change glazing size or properties of a window, that would first and foremost affect your lighting, the quality of light, and heat get into the space. And then if you assume there is daylight control, then those changes in glazing will also impact lighting energy use and the heat input into the space through lighting gains. This would then affect the amount of heat absorbed and released by thermal mass at any point in time, along with affecting the heating and cooling requirements as well, in terms of their loads and energy. So all of these things will affect the efficiency and performance of the HVAC system, and eventually will affect the energy use and carbon emissions. So what you can see is just changing this one element, which we can refer to as the design variable. From now on, we can create all these chain reactions. So this means that trying to fully understand how to optimize a building gets very complex very quickly. And I'm sure you have seen some unintended negative consequences resulting from this complexity, such as overheating in summer caused by well-intended energy conservation measures. So designing high performance, energy efficient, comfortable buildings and high productivity workspaces, we need to be considering building as a whole ecosystem, including its surroundings as well. And not just look at it as components, but also look at the interactions between them. So this effectively is a strong similarity with if you want to have a business or in a sports environment where you can have good individual players, but if they don't work together, then you will not be having a high performance team. So yeah, so how complicated the problem is. So what's the size of the design space and total possible combinations? So for example, in your project, you have design variables such as glazing or amount of insulation or HVAC systems and its controls. Then for each variable, you have number of choices. For example, for your HVAC system, you might have a fan coil unit. You might have with chillers and boilers, or a VRF or VAV, or ground source heat pump, whatever options. Then, for example, if we have 10 design variables and each variable has say 4 options, then you have over 1 million possible combinations, and manually checking them can take huge amount of time and effort. And that's why previously design teams are forced to resort to what works based on past experience and or rules of thumb. Trying to do anything more than that would have taken so long that it will put them out of business effectively. So the answer to this problem, to properly sift through everything and assess the key drivers that will truly optimize the performance of a building, is using optimization. So the whole point of optimization is that it does enable you to quickly and effectively search the whole design space. So, and you can find the optimal combinations of all the design variables. It does this by using the genetic algorithm, which works on the survival of the fittest principle of natural evolution. Using this algorithm, optimization provides design team with a confidence that they can have identified all the strong solutions that are possible in the design. So, and this is what a optimization process looks like in a kind of a flow diagram of sequence of things that happen. So in the first step in any optimization would be to specify what are you doing. So you specify the objectives, the constraints, and design variables. Variables is something which we discussed a little while ago, and objectives and constraints are again optimization terminology that relate to the outputs of your model. So objectives can be things that define success of a particular design of what it is being measured against. So typically you might have 2 objectives which have conflicting criteria. So, minimizing discomfort hours and minimizing energy use. Constraints, on the other hand, allow you to impose upper and lower limits on your key performance indicators, such as specifying the maximum project cost or maximum number of discomfort hours, for example. And constraints are a great way to help the optimization engine to avoid searching for solutions that you don't want. For example, if the building exceeds your maximum project budget, or it exceeds the maximum hours where set points are not met, etc. So once the optimization starts, then the process is automated. The process will generate multiple simulation batch files, which will run in Energy Plus. And then the optimizer will assess each batch and find the strongest solution, which try to meet the objectives which we have defined, and kind of rank them and assess how are they behaving. And then subsequently, it will take the information from the strong solutions and create future batches to run. And the whole process is automatically repeated again and again until the optimizer has found all likely strong solutions. So this is the kind of Pareto optimal front, which gets created, which lists the optimal solutions, which are listed in red dots at the leading edge of the cloud of points which we have. And the result kind of shows all the different combinations, with each point indicating performance of each simulation run and representing each different combination of variables. For example, the x-axis and y-axis in this case show minimizing net site energy consumption and capital cost. And so each of these results represent those two outputs for each of the iteration. White points are generally the ones which are not optimal. Yellow points are invalid solutions because they have failed a constraint. And as I said, the red points would be on the Pareto front, which represents the unbeatable solutions, which have a particular construction cost and the lowest energy consumption, and vice versa. So one of the real strengths of this is that it gives a range of optimal solution based on your design objectives. And this can really help you to focus your design decisions and discussions with your design team and client. And these informed decisions can help you to choose where you want to focus your attention along this cost performance spectrum. That you want to focus on the performance side or the cost side, or somewhere in between. So this is a short sped up video on that illustrates how Pareto front develops for a small model. So design objectives are to minimize discomfort hours and operational carbon emissions, and individual simulations form the point cloud, and the algorithm selects the strongest solution from each batch, slowly migrating towards the origin as the objectives minimize. At the leading edge of the Pareto front, you have the optimum solutions marked in red, and typically you would see diminishing returns towards the ends of the curve. So solutions offering a balanced trade-off between the objectives are somewhere in the middle of the curve, closer to the origin. So now hopefully you have a little bit more clear understanding about optimization in the building performance concepts context, and the underlying principles which work behind in there. So what I'll do now is I'll take you through an optimization case study that was done using DesignBuilder. And the project, as I said, was a teaching campus college building. And because it is located in the tropics, the problem was it's hot and humid. And with regards to energy and comfort, cooling effectively is the most important factor that needs to be dealt with. So I'll be discussing this case study in detail so that you can link the concept we just had mentioned with an example. And I'll first do that by introducing you to the optimization setup requirements of this case study, what are the basically objectives, constraints, objectives, variables, etc. And then we'll move into the software interface to show how everything is set up. And at the end, I'll come back to the slides and discuss the results of the optimization process. So as cooling is the predominant energy end use, this case study aims to optimize the fabric and systems to minimize both cooling and capital cost. The design options under consideration are related to construction, finishes, shading, HVAC, and lighting systems. So these objectives will be there to, for example, to minimize the cooling demand and to minimize the capital cost. And these areas will be the design variables. So through optimization, the design will explore answers to questions such as what is the most effective HVAC system? Can capital expenditure be reduced by having better envelope in case of HVAC system? Or in case of a high efficiency HVAC system? What is the most efficient shading strategy? And maybe can we introduce shading to reduce the need for an expensive glazing? So I will show you briefly the various design variables and the options that were there for this study. So the first category looks at the envelope and thermal performance. It has options based on varying the insulation thickness in the walls and roof. And the issue of thermal mass is explored by changing the location of the insulation in external wall and also varying the thickness of the partitions. Window construction focuses on the U value of the windows. Then a big combination was various shading options were thought about to deal with direct solar gains, because shading is a low cost way of reducing them, and different combinations of shading for different orientations. So gives a large complexity to deal with. Then for surface finishes, besides U value, surface finishes was used as they have been they affect the performance, and they were incorporated by changing the solar absorptance of the outermost material. And on the system side, lighting is a source of significant heat gains, and selection of HVAC system also presents a trade-off between capital cost and efficiency. So all possible combinations of the design variable selected resulted in a very big search space. So now moving to setting up the problem in DesignBuilder. So I'll switch to the model and show you how these variables and objectives were set up. So let me change. Yeah. So this is the case study building model that was created from architect's initial drawings. And looking at the north arrow, we can see that the longer faces are along east-west direction, and atrium has in the center has the provision for daylight penetration into the center of the model. I'll go to the edit screen to show you the model itself. And if I go to the ground floor, you can see the central spine and rooms on either side of the central corridor. And we have got circulation spaces, labs, lecture halls, toilets, facilities which are there in color coded legend. We can see how they are laid out. So in this project, all the layout and activities and everything else was according to the design specification, but there was scope to improve construction, shading, lighting, HVAC. So these were all the design variables used in the exercise. I'll not be going into detailed review of the model data tabs and keep our demonstration limited to the optimization related things. So I'll look at things such as design variable options, etc. So after you have finished all your modeling, we have to follow the same steps that I showed in the optimization flowchart in the slides. So the first step is to define your objectives and design variables. And this is done using the optimization settings option. And you can see the analysis type is set to be optimization. And if you go to the objective, then you can see the two objectives there to minimize the.
المشكلة انك بتقلب كل جيوب وتلاقي جيب كده ما تعرفش جه منين.
Thank you. The design objectives would be to minimize the cooling cost and total cost and cooling energy. However, there are other numerous KPI options which are available. So you can see you have options for cost, environmental impact, and loads, various loads, and then even unmet hours you can put as objectives to control in your optimization. Then on the design variable side, this is the design variable list for this analysis. And for example, this external U value variable, if I change that, then there are 11 options which are created for this. And you can see the various options which are being used. But as I said before, we are playing with the location of the insulation, thickness of the insulation. So all the combinations of those external walls have been put here and selected as variable options. And you can have all other various types of design variable options for different categories, including constructions, glazing system, HVAC systems you can change, and schedules, set points, activities, etc. And there are few nice ones which are custom EMS, IDF, and custom script. These are the ones which are new ones and allow you to bring in even more flexibility in what you can specify as design variables apart from the pre-existing lists which are already there. So there are actually two design variables which I have created using custom scripts. So these are the custom script options for changing the solar absorbance of the materials of walls and roofs. So custom scripts can be used to directly modify aspect of the model, including individual model data entry fields which would be there in your model. So this can be done using the scripts, and you can also do the same thing with objectives as well. You can create your own customized objectives using some calculations which you would want as well. So now moving back to the variables. So we have got variables for external U value, roof, glazing, partition, lighting, and shading for defined for each facade separately. And you would note that target objects for most of the variables is at the building level. However, shading has different design variable for each facade. So DesignBuilder allows you to custom select parts of the model as target objects. So for shading, appropriately oriented walls have been selected as targets. And you can go to DesignBuilder help and website. There are vast resources, including tutorials, webinars, which you can use to learn the setup of this optimization in more detail. And at the end, I'll show you some of these resources that are available to you as well. So cancel that. So now optimization setup is complete by defining objectives and variables. You can go and run your analysis. So you go to your analysis running. Geez. Yep. You go to the analysis tab, and then you can run, and you will see the same interface which we had on the sped up video which I had, and if I run it, it will keep on running, but the process takes time. So I'll move back to the slides and show you the results after running the analysis for this project. So, yep, this is the finalized result screen after 1,000 simulations for this particular project. And the analysis took about 12 hours. And there's a lot of information that now we can analyze to inform designers about the various options they can choose. So for example, again, capital cost is on the x-axis here, and the y-axis has the cooling energy. And red dots, as before, show the solution that occupy the Pareto front. To assist with simulations and complex optimization problems, DesignBuilder can run on your simulation on network server or on cloud, and either you can do it on your own servers, or you can go and use a Jest simulation server here, and you can purchase access when you click on this option. So now looking at the results. So first and the most obvious thing which we can see is the 4 different clusters, and these clusters represent different HVAC systems. And this shows that using more efficient HVAC system significantly reduces the cooling energy use with relatively modest increase in cost. And then within each HVAC subcluster, we can see 3 subclusters for different lighting systems. For example, in the VRF cluster on the Pareto front, we can see that as per the costing information for this project, changing lighting type has greater impact on cost rather than cooling. And similar to this, other clusters and subclusters can be identified and gives answers to questions which we asked earlier, such as, we found that water-cooled chillers with better envelope can achieve similar performance as VRFs, but with 3.5% saving in capital cost. Or the effect of adding insulation and thermal mass beyond optimal levels provides diminishing returns. And shading with simple double glazing can save 3% costs for the same performance when compared to only using an expensive glazing solution. And there are more inferences that were drawn, but the intent right now is to kind of show you the process here. So after looking at that case study in detail, I'll also briefly show you some different example applications of optimization using other past projects to illustrate how optimization can really make a difference in design. And at the end of the webinar, I'll show you where you can find more details about each of these case studies and some additional focused learning for resources. So I'll start with this ground source heat pump optimization study. This was done by Brendan Hall of CHA Consulting in Syracuse, New York. And the project was completed for his previous employer, Karpinski Engineering. The work with optimization focused on optimizing the heating and cooling loads, because the heat rejection loop in the bore fields has a big impact on the size and cost of the ground loop itself. So optimization was used to identify the combination of energy conservation measures that had the greatest combined impact, and not just the energy conservation measures with the biggest individual potential without considering the whole picture. And the result was Brendan was able to reduce the ground heat exchanger length by about 1/3, which offset the cost of other energy conservation measures to further improve the design. This is an excellent example that really demonstrated the impact of intelligently combining key design variables for maximum impact. So in this next project, this was shortlisted for the SIPSI Building Simulation Group Award in 2018. And in this case, Arturo Ordonez of Solarc needed to reduce the construction cost and carbon emissions of a new build house in Spain. And optimization was used to find the best trade-off between window to wall ratios, thermal mass, insulation, glazing, shading, etc. And using DesignBuilder, Arturo was able to find optimal solutions out of 170,000 plus combinations. So when compared to a typical house in that region, Arturo's design predicted a reduction of more than 47% in the carbon emissions, combining both embodied and operational, and construction cost savings of more than 24%. Moving on to our next case study. I mentioned earlier that DesignBuilder optimization tools were released back in 2013. Well, this project was completed in 2015 and was submitted for the ASHRAE energy modeling competition that year. And optimization was used in the entire project design workflow and was completely at the heart of the work which was being done to develop the design. So the project was on a 20-acre development site in Pittsburgh, and for many inner city brownfield development sites, there were a number of challenges and planning constraints, such as tall buildings and surroundings. An important part of the client brief was they wanted a mixed mode cooling building that utilizes natural ventilation to take advantage of the variable climate in Pittsburgh, because there's an opportunity for periods where you can use natural ventilation based cooling. So the client also required the team to present fully costed solutions so they could find the best trade-off between construction cost and performance. And this is exactly the problem which optimization is designed to solve. So this is the overview of the workflow that was followed for this project. And there's a lot to say about this workflow, but I'll keep it in brief and quick pick up the main highlights. So essentially the design was a 3-stage process, and it was to identify the best building form and HVAC systems using optimization. And then once that is done, fine tune the rest of the design with more focused simulations. So at the first stage, the building form and orientation were assessed. Optimization guided towards a rectangular form with an internal courtyard. And this form could minimize loads, provide enhanced two-sided daylighting and natural ventilation. And courtyard was also seen as a great recreational space to improve well-being for occupants. In the second stage then, after the form was done, it was to optimize and identify the best HVAC system and lighting and PV systems. The results show that ground-coupled VRF systems with heat recovery provided the best balance between cost and performance. And then further in this step itself, further optimization was done to fine-tune the heating, cooling, and natural ventilation set point control temperatures. So you can see optimization can be progressively used to fine-tune the design so that it is optimal according to the design brief. And after optimization was done, in the third and final stage, the team used the other DesignBuilder tools, integrated ones, to do the CFD and to finesse other aspects of design like lighting, etc. Overall, the workflow helped the design team reduce the predicted energy consumption by 64% compared to the ASHRAE 90.1 baseline. And total energy costs were reduced by 46%, which is a big achievement. And this workflow was presented at the ASHRAE Energy Modeling Conference audience in 2015 and won the Best Innovative Workflow Award. So DesignBuilder's optimization tools have been significantly enhanced since then, and now we have much more functionality, including the ability to optimize any key performance indicator and using any possible variable by using the scripting stuff which I mentioned earlier. So this covers the key concepts about optimization, and I've shown you 4 projects illustrating how optimization can be used in a real world context to deliver step change in building performance. Before I end, I'll show you a range of free resources which are available, including case studies and previous webinars related to DesignBuilder optimization tools. So if I shift to DesignBuilder website, and you can go to scroll down on the main page here, go to more case studies, and you can see select the international option and see the available case studies such as optimizing a eco-friendly house design, or it's another ASHRAE showdown modeling competition that used optimization. It's also one on performance optimization of a low temperature chilled water plant. So you can do that, or you can go to our webinars page over here. You can find the past webinars over here. So this webinar, design and modeling of ground source heat pump systems. This is the case study webinar on Brendan's project regarding the whole how they did with the ground source loop optimization. And you can look at this webinar for more detail. There are a couple of other ones. They are related to uncertainty and sensitivity analysis. This is a related topic to optimization, and you can learn more about these 2 topics over here. And if you scroll further down, then there is this one, optimizing an eco-friendly house using DesignBuilder. This is Arturo's case study. And then at the bottom, there are 2 case studies which are related to the ASHRAE energy modeling competition webinars. So they provide great ideas on optimization project workflows. So these free resources will give you a great insight into optimization and its applications. And if you're using DesignBuilder optimization and you want to fast track your learning, then you can do this. But there's a online training course as well, which you can do. It's at the bottom of the page. You can see optimization fundamentals course. So this course is a cost-effective way to quickly learn about it, see what to do, what not to do. It will save you a lot of time figuring out yourself, setting these things up. And course will cover optimization concepts, will give you a rigorous introduction, and effectively setting up and running full optimizations in DesignBuilder. And really important part of the whole optimization exercise is to interpret and look at results and identify them. So you'll be able to start getting to grips with those. And alternatively, just if you want to just get started, then you can go to DesignBuilder program help. So support program help, and you can see there are lots of help tutorials which are very step-by-step available in the program help, which will get you started in using and looking at some of these results. So yeah, so there's a quite a big list of these tutorials which are from basic level to really complex applications as well. So back to the slide. So yeah, this is before I I'll finish basically by reiterating that optimization makes it possible for you to assess the full range of design options in commercially viable time frame, which is effectively for normal projects, and gives you full confidence that your recommendations are optimal and you can make your client happy, that you have done everything realistically possible to optimize their building, and also can be used to reduce your design risk. So yeah, that's the end of my my piece. Back to you, Danny.
Thanks very much, Nishesh. So we have a bit of time for questions. There's a couple already in the chat. If anyone else has questions, feel free to type them into the chat, or you can use, as I said, the raise hand function. So that's under reactions and raise hand. And if you do that, I'll just let you know when you can unmute yourself and come on and ask Nishesh a question. But just for now, I've a couple here. I might just start with the relatively straightforward ones before asking you the ones that are a bit more in depth.
Sure.
So one was regarding the minimum number of iterations to find the suitable Pareto front. I guess this kind of is depending on case, but is there any kind of general recommendations you have around number of iterations?
So that is so number of iterations required would be depending on obviously the complexity of your design search space, and also so basically how many variables it is and how different they are. But there is a rule, like if you have so right now in DesignBuilder we use NSGA2 as the optimization engine, as an algorithm which runs. So no, these are efficient ones, and you can be sure, like if say for some number of generations you don't end up seeing any Pareto optimal results, then there are chances that most of them are kind of found. So yeah, it's a balance between time and things. For example, the example which I showed, we had about 1,000 iterations I stopped the analysis at, and that was good enough to give me results. I did run it for another I think about 2,500 runs, which took me a little significantly more time. But between those 1,000 and 2,500, I did not get any new interesting insights. So it was was there, but my suggestion would be, if you are doing a complicated, complex optimization problem, don't bang in every possible permutation combination and everything. Actually, you should try and make some intelligent optimization problems by maybe eliminating the obvious variables out and minimizing your source space as much as possible, and sensitivity analysis of your model, as using sensitivity as a precursor to optimization, can really help you make the process more efficient. And in the webinars page, I think I remember doing a webinar on using sensitivity before optimization. There would be one in that list of webinars if you go and find, that will be able to give you some more insights into how to do it.
Okay. Thanks, Nishesh. I have another question about cost data. One question was just where do you enter that information into DesignBuilder? And then I had a further question about the source of some of that information, because you talked about objectives in terms of energy and carbon emissions, and they're possibly a little bit more straightforward, but cost data, is there any reference that you use for some of the solutions you spoke about within DesignBuilder, or is it all user inputted data?
So cost is a very tricky component in my view, and the reason it is tricky is cost for geographically as well for two different projects would be very different, can be very different for the same type of thing. What about if you have a good deal from somebody to procure something at a lower cost? So cost is a very flexible. So DesignBuilder does have some default numbers to put in for cost numbers, but you would always and they are based on historic cost informations from various different sources just collected together. But they're, in my view, they are more placeholders for your project. Like for the example which I showed, I would go down and for example, each material will have its own input field to change the cost for. So I'll go change the cost for each material there which I've got, the system which I've got, I'll put their costs in, and lighting system, etc. I'll put their costs in for my project, and then use that for informed decisions. It's very tricky and difficult to do that. Having said that, if you are doing it in a structured form or something, you might have your cost book or something. Then if you have that, then you can bunk all those numbers in once and then copy them across. So we put them in the library, and then you will be able to use that cost information instead.
And just one further question on cost. I mean, that covers the capital costs for some of these items, but in terms of the operational cost calculation, do you take into account things like tariff information, time of use tariffs? Is that possible, or is it fixed?
So you can have tariff information defined. So you define cost tariff information, and because you can also do life cycle cost as an option. So you also can define for how long you want to do these costs for, and what is the change of these costs. So there is these are reasonably easier fields in DesignBuilder to set up as so there's an economics tab in DesignBuilder where you put in all these cost tariff informations and life cycle related things.
Okay, thanks, Nishesh. There's a couple of more detailed questions. One in regards to the Pareto frontline. It's sometimes hard to find a Pareto frontline when we do not use the default optimization variable in DesignBuilder. I don't know if you have any comments on recommendations, maybe for how you set up your optimization problem to avoid that issue. Is there something to?
So it would be, I did not get the total gist of the question completely, but so the reason why you would not get a good Pareto line would be, there can be two reasons, and that is important for defining the problem. So if you define a problem in which both of your objectives effectively are not conflicting with each other, then you will not have a Pareto front, but you will have like a V thing where we have a very narrow band of things. So Pareto is effectively a balance between something is more and the other thing is less, and the other thing is more and this is less. So if you have not set up your objectives correctly, then you might not see Pareto curves, because the solution which you are trying to get to is already known. For example, you can, if you reduce your, for example, if I put my option as site energy and carbon emissions as two objectives, unless there is something, both of them will lead to the same answer for each of the things. So you have to be a bit clever in defining the problem. And if you would want to understand setting up of these, as I said, please try to look at the previous webinar which was there, and that actually covers this idea of defining the problem itself. So that would be able to solve that.
Okay, I think you may have touched on this next question during the session, but it was in relation to ventilation strategies and whether these can be optimized for both energy efficient operation, but also to satisfy thermal comfort requirements.
Yes, so yes, you can. You can use natural ventilation control temperatures or size of the opening, etc., for natural ventilation to come in as design variables, and they are actually, you don't need to use any scripts or something. They are predefined variables already available to do those, and you can have your comfort and energy as the two parameters. So yes, that is possible.
And there's a last question here from John about whether, and I'm not sure if you can provide it on the webinar, but an indication of annual price per professional license for the functions that you presented, or is this something that you have to just contacting?
So I would say price information is something I will not have on ready with me here, but you can. I think there is a pricing structure available on the website, if I'm not wrong. Irrespective of that, I would maybe request John to maybe go and there's a at the bottom of this slide there is info at DesignBuilder. So either to that email, if you can send this request to discuss these functionality, or alternatively sales at DesignBuilder is also there who will directly, but if you send the email there, they should be able to reply to you on that.
Okay, thanks very much, Nishesh.
Yeah.
So I'll just we're at 3 minutes to 2 now, so I think we'll close the questions there. Sorry, did you have something else you wanted to add?
Just one thing, in case if John wants, he can send his email, and I'll be able to ask the sales team to look at and send back information to him.
Okay, perfect. So thanks a million, Nishesh, for a really interesting, insightful presentation, and thanks for sharing that with us today. I'm just going to run through a couple of closing announcements before we wrap up. One is just in relation to our student awards, which are now in their third year, and we're announcing the winners on this Friday at our webinar with Tom Lawrence. So you can find details of that webinar on the slide I presented earlier. So there's a download actually and a link in the chat, so you can see, or you can check our website. So just after Tom's presentation, we'll announce the 3 winners for this year's ASHRAE Ireland Student Award. Another program that we're really excited to announce is the mentorship program in collaboration with CIBSE Ireland, which we're running for the first time this year. And the idea with this is that it's to assist young engineers or graduates at early stages of their career journey by pairing them up with more experienced mentors. And we believe this will be really beneficial for both parties, both the mentors and the participants in the program. And we're actively looking for people to sign up to that, either as participants or as mentors. On our website, and the first webinar, or the first, I suppose, networking session in that program will be held on the 25th of November. So you can find more details on that on our website. I've just included as well just the current ASHRAE Ireland board for this year. If you have any questions about any of our activities, or you're interested in volunteering, feel free to reach out to any of us at any time, and you can find our contact details on the ASHRAE Ireland website. Just to stay in touch as well, if you want to keep updated with upcoming events and training and seminars, you can find the details for all of our social media and mailing lists on this slide. Most of them you can find the details if you just go to ashraeireland.org. You'll be able to sign up for most of these on our website. So that's it for today. Just before we go, I just wanted to say a final thank you to our sponsors and supporters who have been fantastic over the last couple of years in ensuring that we can maintain our activity as the Ireland chapter. So with that, I think I just thank you again, Nishesh, and thanks everyone for attending today. As I said, the copy of these slides and today's webinar will be up on our website later today or by tomorrow at the latest. But thanks again, everyone, and enjoy the rest of your afternoon. All the best. Thank you.